participating in today's data meeting. And we are looking at lesson 29, which goes over standard 8EE, 8C, analyze and solve linear equations in pairs of simultaneous linear equations. In order to solve real-world mathematical problems leading to two linear equations and two variables. So the first thing I want to do is offer Mr. T like some serious praise. The two things that I have regarding praise for this math teacher is that your planning and your time spent preparing for lessons, I think, is like exceptional, and the relationships that you have with students in your professional relationships with students is like super high in terms of like the high expectations you have using the Engage New York curriculum. So I want to honor that first and foremost because Mr. T does a great job with using the Engage New York curriculum. All right, so let's take a couple of minutes and dive into this standard and come up with a list of knows and shows for this standard just based on the wording. All right, so take about a minute or so to look at it, and then I'll ask for what you guys want me to put down in terms of knows and shows for this standard. Okay? Take a minute. Let Mr. Mack and Ms. Palmer. And if you add after they start, all right. What do you think, Mr. Mack? What do the kids need to know in order to be successful and master this standard?
The components of a linear equation, from there needs to be numbers, a variable, operations, and an equal sign. The process by which they can isolate the variable. Depending on what process you use, I like to use the rule of opposites. So if it's like multiplication, I use division.
Now, well, you're getting the shows. You're getting the shows.
Sometimes,
yeah, go ahead.
Okay. So when it comes to the process of isolating the variable, whether you're going to use the reciprocal or whether you're going to use the opposite operation, I guess will be what they need to know and show.
Picking an operation?
Kind of.
Or a problem-solving technique?
Yeah.
Okay. Homer, did you have anything to add?
There's the equation of the line specifically. This is kind of a show. I'm thinking of like you need to know a good starting point. So that's kind of what Max talked about, like a model, but like.
But I kind of went past the whole developing.
I'm just thinking of like easy points. I don't know how you want to say that, but a starting point.
What did you just say?
Well, I kind of went straight to solving the equation without actually developing the equation, which is part of it solve real-world mathematical problems, which means they're going to have to read a real-world situation and develop their own expression or equation from that, which is the hardest part of it. So
do you want to?
This goes back to
what if it's something under no?
So they have to know how to annotate.
Like, is that what you mean?
Yeah.
Reasonable? Okay.
Exactly.
Yeah.
And annotate
and express.
And then draw a diagram or a model.
A numerical representation or something
a model.
like that. Yeah.
I mean,
right. Or
even
you
if you
do
drew
that,
like in fifth grade, you draw like a rectangle and parts, or you know.
Right.
I don't know.
Cool.
Yeah.
So yeah, I think that's a great know and show chart for this standard. And so what I want to do next is go ahead, Mr. Matt. Oh, I thought you were raising your hand.
Oh no, I'm sorry. I was just observing.
What I want to do is show you an exemplar for this lesson. pick these problems and take about 2 minutes or so, and you can annotate on them and see if I missed anything when I was working out the problems.
You didn't annotate.
Well,
Just right off the bat.
The sum.
so let's after we do that, we'll do an exemplar no and show
Okay.
for this lesson.
It's kind of weird. It's like I'm annotating a bit further. Knowing what I know, you know what I mean? It's kind of weird. Yeah.
All right. What about this exemplar work? In order for not just to get the right answers, but to kind of be on the same page in terms of know and show, what does, give me some no's for the exemplar. In other words, in order for kids to do well in this assignment, what do they have to know and show that may be the same or different than our standard knowledge? Mr. T?
Okay. They have to know what simultaneous linear equations mean, meaning they need to know that they have to have two equations. Or systems of linear equations.
I'm trying to figure out how to write that.
Two or more equations.
You have to be able to solve it. But yeah.
Because you can look at these problems and if you're not very
You need
familiar,
to know
you might think that you need one equation.
two equations.
Especially because like it's written, the sum of two numbers is this and the difference. Like.
Is it like two equations described by simultaneous relationships? Is that okay?
I just say two or more with them. Either way, you know. So, I mean, to shorten it.
Right.
But we should all know, or knowing 8th grade math is simultaneous. When the equations have more than one.
Okay, cool.
Right.
What else?
It kind of brought me to like I started annotating at like a 5th grader, so I saw sum, and so I don't know if that's a no. Yeah, I need to know that sum means addition.
Okay.
And difference
Math.
means.
Math vocabulary.
Yeah.
Yeah. Okay.
Basic math
I
vocabulary.
just call it translating. Is what I tell the kids. Like.
I say algebraic language.
Yeah.
Yeah. That goes with it.
But I'm like, is algebraic language like sum, or is it the addition sign? You know what I mean?
It's both.
But
Yeah. But
Well,
I want
and then
them
like,
to
what
see
does it mean when
sum
two
and
things are
know-
next to each other? The same kind of thing,
yeah.
right?
And then
Well, keep going.
You're gonna need
It's
to
like the same thing as like is.
know to
My
combine
5th
like
grade brain
terms.
tells me is always an equal sign.
check
Yes.
around like
Is
time.
that too
Yes.
basic? Well, when they're gonna need to know that they need to, that if there's two variables within an equation, the only way they're gonna be able to solve it is if they have two equations to compare to each other.
Right.
So you're
I
combining
said I
like
called it
terms.
isolating one variable. The only way to solve this.
Isolating variable or math operations?
You have to be able to
Yeah.
combine like
Isn't that called
terms
two-step
and
equations?
Combine like terms if you want. I call it
Yeah, but then
isolating
we're
variables.
talking
It's
about
the same thing.
We're talking about solving linear equations because I mean it's all under one umbrella. You have to know to isolate the variable.
Yeah.
You have to know how to what was I just about to say?
That's what I said.
Combine like
Combine like
terms.
terms.
Yeah.
Yeah, they're kind of the same thing.
You have to be able to solve two variable equations.
And then I also like I was thinking as like a child brain. I said, how would I know which one is which? Because I'm thinking like, what are two numbers? A 5th grader would solve this by guessing.
Yeah.
Do you know what I mean? But like 8th grade is how you did it, which is isolate one variable, then substitution. Like you need to know what is it, a rule, a law of substitution?
Well, it's using substitution or elimination, right? Being able to distinguish
Oh, right.
between
I always
elimination.
go to it.
So that's more like
And with
you have to know this, right?
yeah, and with that substitution, elimination, to do elimination, you have to know what inverse operations are.
Yeah, to be able to successfully do eliminations, where substitution you could just plug it in. You know what I mean?
Going back to what we have it up here. Okay. Cool. That's awesome. If you go kind of and look at this post show chart on that side, and the chart, is there a gap in between this? Is there anything that we need to add in order for the kids to be successful as far as what we're looking at on this particular assignment?
Annotation.
Here.
Yeah, that's what I
And
said.
that's just real world. I mean, they can figure out the problem without annotating, but at the same time, maybe you talk about real world, knowing what the words actually mean.
It's also
Whether that's
strategy to
annotating
check.
or
You know what I mean?
Yeah.
Same
Like
thing.
now that I have an answer, I'm gonna go back looking at my annotations and I could quickly check. If you don't annotate, then you have to reread the problem again.
Right.
Almost from scratch.
Right. Think about that as we look at the student work. So let's look at student work. Let's pass out some student work and see what the gap is between what the kids did and our know and show chart. And just in the honor of
this first problem? Or?
well, for the whole, no,
Okay.
I was just giving you an example of what the problem
I mean,
is.
it's just, I don't know how much you want.
Just do a couple. And in full transparency, I'll take a couple. If that's okay. I talked to the 8th graders today at break and at lunch, and got some information from them about this assignment as well. That was very, very interesting conversation. Great.
Conversation what?
I will tell you. I will tell you.
Can I?
Can you tell us what was the assignment? Because it seems like some of them only did one
Thank you.
from at the top of each page. You know what I mean? I just want to know what they were expected to do.
So we did these problems together. They were expected the one that no, he didn't talk about that one yet. The one about cows and chickens.
Yeah.
They did that one by themselves.
But like the blank ones are the same.
Well, we
They
didn't do
them. You
we didn't do
them.
example number 4,
Gotcha.
and example number 1 was done the day before. So if you don't see example number 1, they either got a new packet or they weren't there that day. I also tried to do problem set number 1 on the back, because that was exactly like example number 1.
Okay.
So we were trying to emulate.
Right, the language is the same as those.
We tried to do that one again. There's more information.
Gotcha.
Remember that you're thinking about what's the highest leverage, something that's highest leverage that we could offer this teacher on getting the kids to be successful according to our show chart and no chart.
You have like another student that's not so good?
Who's that?
America?
And once again, doing the word problems, we did a lot together with obviously prefacing and dragging out answers, random selection. Oh, math is boring. Cool.
That's some of the wrote. I get little notes like that all the time. This sucks.
Did they work on the exercises themselves?
Yeah, right. The exercise
one?
1 they did.
I think
Partners.
exercise 1. They were,
So-
they
Or
gave
all
it a
by
shot
themselves?
themselves.
All by
Oh,
themselves.
And I like that. Thank
Oh.
you, Mac, because I want to focus on that. Let's focus on that one actually. Exercise 1. I think that's when you said that the kids did it on their own, correct?
But after they do it on their own, I for sure do it on the board. So a
Right.
lot of them choose to copy it down.
But you can see, yeah, they, but
But
even
you
if you
don't
do that, you
necessarily
can
know.
see like a bunch of, you can tell they like added stuff to it, and you can see where they messed up.
Or where they
Sometimes.
were at before.
Yeah, where, exactly.
So what I'm doing is I'm taking my exemplar that I gave you, and I'm looking at how this exemplar for exercise 1 compares to like the kids. Okay, so see to do that, and we'll see if we see gaps. What I did in my exemplar kind of mirrors what we said that we the kids need to do really, really well.
This kid used animation.
Oh wow.
He used substitution and he got the answer. So it's completely different than that.
Who's that?
IG. And I didn't do elimination for this one. So I know he did that one.
That's exemplar, yeah. Are there any misconceptions that are striking out at you?
It's hard for me to tell if the kids knew either what elimination was or how do I make the equations ready for elimination. Do you know what I mean? Like so either how do I multiply one of the equations to get the variable the same amount and it already has an opposite sign, or then how do I distribute a negative because I got that far, able to multiply, but how do I get it ready for elimination? Do you know what I mean?
Yeah, how to set
What
up.
do I need
Yep.
to do? It's kind of like the on the road, right? Where am I going? How do I get there? Like it's not striking me clearly. But I did think it was interesting that even the kids that didn't use X and Y for cows, like one kid put W and K, I think, for chickens, like they knew that the two animals were representative of different variables, so they needed to be different numerically. Do you?
Yeah.
Like, I feel
Did
like
you
that
see-
demonstrates that.
Did you see that as common, or was that 1 or 2 examples?
No, that was all of them that I've looked at. So, did you see that, Mac? That they knew that the cows and the chickens, like in this first problem, cows and the chickens need to have different variables.
The one I'm looking at is, yeah, I mean, the two I looked at, they both realized that,
Yeah, they were both able to see that like
Okay.
they're not going to be the same. You know, like,
Was that enough to convince you, like you're saying, that they knew that the variables had to be different? Was that enough for them to annotate and express the model?
some of them didn't get the equation right, so I don't know if that necessarily demonstrates understanding of a model, but it's part of a model. Do you know what I mean? It's the part that the numbers are different.
And if they don't get the equation right,
Then we focus on that.
well, if they don't get it right, then they're not going to get the rest of the
Oh, right,
understanding.
right.
So
That's
go,
the hiccup where
go
we
back.
lost them.
I think that's the hiccup. I think that this is the gap right here.
Yeah, because like one of the kids went back and forth between whether or not which side they needed to put the 114, like was it equals, even though it says total of, which should be an equals.
Yeah. And in my conversations with the kids today, every single one of them said this. They said, we're struggling getting the equation right and setting it up
So it wasn't
because
doing
it's
the
hard
math.
to understand.
Right.
It's not doing the math. It's setting up the equation, understanding what the problem is asking, and then setting up the equation so it matches the problem.
Right, so getting ready for elimination.
Yeah.
So listen.
Exactly.
So those two things.
So I think that's the gap. Does everybody agree on that?
Absolutely.
So
It's like you almost have to have a conversation about positive and negative numbers and how like,
wow.
you know what I mean?
Let's
Like
form,
take
yeah, let's
people
form a
away.
reteach. Let's do a
'Cause that's
reteaching
like
plan.
algebraic understanding of
Yeah,
like,
exactly.
of like what are we actually doing here? You know what I mean?
So
Rather than just like let's get there, why are we doing that?
So what I put as the gap for this is that students are struggling with properly setting up the problems. They are having trouble understanding what the question is asking and applying the linear equation model to solve the problem. And so what I would like to do is offer Mr. T some guidance in a reteach plan.
Yeah, so like I wouldn't focus so much on word problems. My reteach plan would be more on just giving them the equations and how do I prepare a problem for elimination.
But getting the equation right is,
Right.
it's not the equation. No.
No, but I'm just saying I would take a step back,
But
do
but
like
the kids
half the lesson
the
on
kids
that.
are the kids are like ready to go with the math. They're having a problem. They're having issues with reading the word problem and setting up the equation that matches the word problem.
And I didn't get to say it, but I think that's 100% right. Because the one thing I tried to do was, example number 1, I felt was the same way as problem set number 1. And then when they didn't get it, or not, we didn't get it, I was very upset at them. Because I felt like example number 1 and problem set number 1 are the exact same terminology.
But I'm thinking maybe if you did more practice on the getting it ready for elimination and the kids wrote their own problem based on the equation. It's like that back
Something
and
like that, but I
forth,
feel like we don't get enough word problems in real life. So we were doing this
let's
for
do
a couple
this.
problems.
Yeah, exactly. Let's do this. Let's choose which one we're going to use, whether it's a modeling or a guided discourse first. So which one would you use as a reteach, kind of like as a reteach plan? Would you use modeling or guided discourse? Remember, modeling is like giving the kids a step-by-step and then helping them conceptually understand what they're doing. Or would you do that guided discourse where you just let the kids work in groups and decide on their own what's going on? In this case.
I think we said modeling, but I've done a lot of modeling with annotation. And I see kids, even that I don't feel like I connect with, even if they don't have anything, they circle and underline. But then it doesn't translate.
Okay, so
Right,
I
you're just
agree.
going through the motions of taking notes.
I agree. So we're going to do a modeling reteach that is going to help with exactly what you're talking about. So, Mr. T, write this down.
We need more CFUs in the middle of your model. Bing! What do I win?
Well, you haven't won anything yet.
Bing!
So here's what you're going to do is model precisely the thinking when moving through a specific task. I have a copy of this for you in a minute, but so it's a modeling lesson. That's what you're going to do. And then how you're going to do that, there's 2 big steps. You're going to model replicable thinking steps that allow students to follow directions. And you're going to give students a clear listening / note-taking task that foster active listening of the model, beginning with an exemplar and then taking them through the process of annotation, making an illustration, and like Ms. Palmer said, checks for understanding. So what I want us to do is, given that information and using this problem as the exemplar,
Step 1, what are the 2 variables?
what would that script look like?
Step 1, what are the 2 variables?
Well, let's write it down.
Oh, okay.
So individually, we're gonna individually do it, and then we're gonna combine our scripts and spar.
So the cows and chickens?
The cows and chickens. What would your modeling lesson look like? You have 5 minutes for this. Write a script as to what a modeling reteach.
I'm not trying to say this in a negative manner, but shouldn't I do something different than I normally do?
Let's do it with this.
No, but you understand what I'm saying? Like, normally, never mind. I'll just, okay.
Yeah.
But,
What do you mean normally what?
So how is this not different? So sorry.
Meaning-
We're trying to.
he's
Meaning
he's
saying,
just
I've
gonna
done this
rewrite what he
before.
already did.
I've done this before. I'm about to say, oh, I annotate first, but that didn't work. So I gotta.
No, but you
shouldn't I
have to-
try something different right now?
Yeah,
You
that's
have
why
to
we're here.
literally-
I know.
I'm
but
gonna give you a
saying-
bunch of stuff right now.
I know,
Might
but I'm
be
saying
different.
I should myself
Yeah.
try something different.
Yeah, sure.
Yeah, you don't have to keep doing
You don't have to keep doing the same thing. And
Well, no, I know that, but I'm
That's the
saying.
definition of insanity.
You understand what?
We'll help you out.
And then we tell kids to like have done. Keep going.
I know, and keep persistence. It's the balance between persistence and changing, pivoting.
Question.
yes.